Hello Pre-Calc Excel students, and welcome to lesson 6.4, where we're going to take a look at vectors and the dot product. Just so you know, we do not cover all of this section. We're just going to look at the dot product and how to find the angle between two vectors. So if we let u be the vector with components u sub 1, u sub 2, and v is the vector with components v sub 1, v sub 2, by definition, the dot product of u and v, we write it this way, u dot v, and we actually say u dot v. This is not, we don't say times, we say dot. U dot v is equal to the sum of the products of like components. So we multiply u sub 1 and v sub 1, we multiply u sub 2 and v sub 2, and then we add them together. When we complete this process, we end up with a scalar. So here are some of the properties of the dot product. U dot v is equal to v dot u. 0 dot v is equal to 0. If I have u dot v plus w, that's equal to u dot v plus u dot w. V dot v is equal to the magnitude of v squared. If I have c times u dot v, that's equal to c times u dot v, which is equal to u times c dot v. Or I'm sorry, u dot c times v. And again, this is where c would be a scalar. So if I'm multiplying the dot product by a scalar, I can multiply either of those vectors by the scalar and then perform the dot product. So find each of these. So pause your video, go ahead and find each of these dot products. Come back when you're done and we'll compare solutions. Okay, so for letter A, hopefully you ended up with -6. For B, hopefully you ended up with 0. And for C, think of u as having a 0 for its horizontal component. So the dot product ends up equaling -8. Okay, now here we have 3 different vectors, u, v, and w. So again, pause your video and find each of these. Okay, A, B, and C. Come back when you're done. Okay, let's see how you did. So we have u dot v times w. Now notice when we do u dot v, we end up with a scalar, and then that times vector w gives us another vector. Okay, so the dot product of 3 vectors brings you back to a vector. So what do you think it would be for 4 vectors or 5 vectors? Okay, think about that. For letter B, hopefully you ended up with -2. And then for part C, if we have the dot product of u with itself equal to 7, what is the magnitude of u? Well, the magnitude of u is equal to the square root of the horizontal component of u times itself, right, plus the vertical component of u times itself, which what we actually have under here is the dot product of u dot u. So if the dot product is 7, the magnitude of u is √7. Okay, if theta equals the angle between u and v, then the cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. The proof of this, I gave a proof on the last page of your notes. You can read through that when you're done watching this video. So find the angle between u and v. So go ahead and plug into this formula, calculate this, and then find the angle theta. Pause the video, come back when you're done. Okay, so let's see how you did here. So we have u dot v, so that's negative 3 times 1, plus 0 times 6, so that's just 0. The magnitude of u is just 3, and the magnitude of v, we have the square root of 1 squared plus 36, or root 37. So I have negative 3 over 3 root 37. Now, as soon as I see this is negative, I know that the angle between my two vectors is going to be what kind of angle? Hopefully you set obtuse, right? Because if I know if the cosine of theta is equal to a negative, that theta is going to lie in quadrant 2. So it's between 90 and 180. So take the cosine inverse. Remember, this is what cosine theta equals. Take the cosine inverse of this value, and you should have ended up with 99.46. Okay, our last question. Are u and v orthogonal? Okay, that word orthogonal means at right angles. Okay, or are these vectors perpendicular to each other? So how would we determine that? If they're perpendicular to each other, what is the angle between them? Hopefully you said 90, right? What's the cosine of 90? 0, right? So basically what we need is for the dot product to equal 0. So basically you're being asked, does u dot v equal 0? Okay, so let's see what happens here. We have negative 12 times 5/4, and we're adding that to 30 times a half. So we can reduce, and we end up with negative 15 plus 15. Oops, what did I do there? That's not a 30. Excuse me. Half of 30 is 15, and we do end up with 0. So are they orthogonal? Yes, they are. Okay. So with this in mind, let's go back to that one example right here where you got the dot product of 0. Right? What does that tell us about u and v? That they're at right angles, right? And if you take a look at how you would draw these vectors, 2i plus 2j, that's in quadrant 1, right? Where the angle, the direction angle would be 45 degrees. And then if I have 1 minus j, where's vector v? It is in quadrant 4, right? I'm going down 1 and over 1. Oh, I don't want to make that look like a double arrow. There we go. So the angle between them, again, with a direction angle of 315, right? Which means that I do end up with that right angle between the vectors. So there's an example of vectors that are orthogonal, and we know that because of the dot product equaling 0. So that concludes our lesson for section 6.4. Again, this is all of 6.4 that we are going to cover. So it's mainly knowing how to calculate the dot product and how to find the angle between two vectors. So I hope you enjoyed the lesson. If you have any questions about any of the examples, please ask in class. Have a good day.